Hello, good morning, everybody. Hello, hello. Uh, is anybody online? Hello.
Hello.
Hello,
Yeah, hi Kumar, this is Giridhar.
Giri, this is Gauss.
Yeah, hi Gauss. Gauss, can you call Siddha once? I think Siddha is not online.
Yeah, I'll call.
Okay.
Hello, this is Siddha Jain here.
Hello, hi Siddha, good
Hello, hi
morning.
Siddha, good morning. Hello, Guru.
Yeah, we start at
We start at
7:70 now.
7:70. Okay, okay అండి.
Good morning, everybody. Is everyone able to hear me?
Yes, good morning, Kumar.
Yeah, good morning. So it's Giridhar, Gauss, Mahesh, and Siddharthi. So we all spoke the other day, right?
Yes, Siddharthi was not joined last time.
Yes, Siddharthi was
Okay,
not joined last time. Okay.
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 I think there's an echo, right?
I
Hello?
think there is an echo, right?
Yeah, some echo is there.
Yeah, some echo is there.
Let me disconnect something in this one.
Let me discuss the company.
Hello?
Hello.
Hello. Yeah. Good morning. I think I'm
Hello?
audible
Yeah,
right
good
now.
morning. I
Yeah,
think I'm audible right now.
yes, yes.
Okay. Yeah. So can you please go ahead and ask any
Yeah,
questions
so
before we
can you
start?
please
How
go
we
ahead
should?
and ask any questions before we start? How we should?
Or still there is an echo. The voice is getting deeper.
So is it okay if I
So is it okay if
exit
I
the meeting and
exit the?
everybody attend it back?
Is it okay if I exit?
Okay,
Hello?
we'll do that.
No, no, no. I think someone else was not on mute. That's why it's echoing. Now it's perfect, right?
Yeah.
Yeah, now it is perfect. I think
Yeah.
not getting
Yeah.
echo.
It's because of someone's mic. Either someone is using what the regular speakers. That's why it's echoing. Okay. So before we start, we already had the demo on what it's going to be exactly. But if you have anything else in mind, please do ask the questions now.
I think Siddha have some doubts. Siddha Reddy. I think Siddha Reddy, you can ask Kumar. Okay.
Yeah. Hi, Siddharthi.
Yeah. Hi, Harold Kumar. Hope you're doing well.
Yeah, I'm doing good.
Yeah. I'm very sorry. Actually, I was in travel. I'm not really. I came to my hometown. Sorry if my end.
Okay.
I'll continue. I mean, I'll continue to listen to your class. If I have any queries, so that from my end, it will don't be disturbance to you guys.
Okay.
Thank you.
Um, yeah. Just give me a moment, please.
Yeah, please.
I'm not able to share my screen. I'm just working on that. Just give me a minute. I think I need to call Ramesh. నన్ను కొంచెం ఆర్గనైజర్ చేస్తారండి ఆర్గనైజర్ మీటింగ్ ఆర్గనైజర్ హలో యా Uh, so everybody could see the screen, right? Mahesh, can you please switch off your camera? Hello? Yeah, thank you. So, since today is the first class, uh, we'll just start with the blockchain glossary to be exact. We'll write down all those things, and from tomorrow onwards, we'll just start looking at one each and every thing that is involved in the concept. Okay, right. Now, this is the online link for blockchain demo. It's not owned by me, but you guys can just have a look at it after the class, right? So, let me open a notepad. Oh, sorry. Okay. First, what we're looking at is something called as peers. So, what is a the first thing that we'll be looking into is peer, right? And then uh, something called as block data. That's the second thing. And then we have something called as hash. Okay. And next we're going to the we'll talk something about Genesis block for today. Block, and when we say add new block, okay, we're getting something called as previous hash as well as the hash of the block. We'll see what exactly it is. Great. So coming to point number one, what exactly is peer? Yeah. So I assume that everybody is from computer's background, and is everybody able to hear me? Can you just post a message? Hello?
Yes, we are able to hear
Yes,
you.
Kumar.
Uh,
Great.
the first thing in the blockchain course or whatever it taking to is the first thing is called peer-to-peer network, right? Peer-to-peer network. I'm just giving definitions of each and everything, and from tomorrow on, we'll start looking into each and everything in detail, right? So the first one would be peer-to-peer network. What exactly it is? We have different kinds of networks that are available right now. That is single, one-side network, two-sided network, and peer-to-peer is something that is not completely decentralized, but it's like we can move from one node to nth node using a particular graph. Okay. Uh, Now, this is a peer-to-peer node wherein, I'm sorry, exactly. Just bear with me for one day. I haven't copied my presentations into this slide, into this system. That's why I'm unable to give it on my thing. You're okay with that, right, everybody? Hello? Hello?
Yes, Kumar.
I'll
You
share,
can
yeah,
continue as like you want today.
yeah, I'll share the course content by evening, right?
Yep.
I'll share you the slides too, what exactly it is. So what exactly happens in a peer-to-peer node is Instead of joining into the complete network, we join to the adjacent computers on the network, right? We join to the adjacent computers on the network, and from there we try to download the content or push the content onto the network. Okay, now exactly. Now if you see this, right, there in a peer-to-peer network, what exactly is happening is there's no central server or something. When three nodes start communicating with each other, that can be termed as a peer-to-peer network, right? It's that the first node is not completely connected to the second node, okay, but the other two nodes are connected to each other. That is, the second and third node are connected to each other, and the first node is not connected to both the nodes, but it can be connected either to the second or the third node, and this way the information is shared between the three nodes, and at each and every given point of time they maintain quorum. That is complete state wherein the data is uh, at a constant state at each and every node. Okay, so in peer-to-peer networking, it's not mandatory that you're connected to each and every computer or the node in the system, but you have enough privileges wherein you can download the data and then push the data onto the network. That is first thing, peer-to-peer network. Next, block data. What exactly is block data? In case of the blockchain or the Bitcoin transactions, the block data is nothing but the transactions that we do over the network. Let's take a look at that. All right. So now this is a block that has been mined recently. Okay, we'll talk about each and every detail. I even spoke just now about mining, right? So this is the block data that has been mined recently, and height of the block data is nothing but the latest block number. Height is nothing but it in the complete chain. What is the latest number? Okay, this is a timestamp, and in here in Ethereum, we are looking at the block data as these things. That is the number of transactions involved in each and every block, right? If we open that link, we could see the number of transactions that are part of this Ethereum block. Okay, the transactions are nothing but it can be an Ethereum, as you're seeing here. You're even looking at the tokens that are transferred from one address to another. Okay, so this is the block data in each and every block. Next, hash and parent hash. Okay, let me take you to a simple hashing example. Look at the implementation later. Okay, so what exactly is a hash? A hash is a fixed length string. I repeat, a hash is a fixed length string which would actually verify the uh, credibility of your message, not the authenticity or something else. It would verify the credibility of the message, stating that yes, this was the same message that was intended to send to you by the sender. Let's look at it, how we are going to achieve that. We have different algorithms for this, that is the SHA-2, SHA-256 and stuff. Let's see. Hello, demo session 1. Now, as you have seen, when I started to enter the text above, you're seeing that a hash is generated. Well, the uniqueness of hash is even with the change of a single character, the entire hash is changed, right? And it's like based on the kind of algorithm we choose. As you're saying, it's SHA-256. Whatever be the amount of input, okay, the length of the output is fixed. So even if you have one character to it, okay, or you have an entire paragraph. See that. As you can see, the content of the sample text that I gave, okay, whatever that might be the content, the length of the string hash string is fixed. Okay. Now, since it is SHA-256, it can be of 256, but it can be of even lesser things. But this is the SHA-2 is the algorithm that is being widely used, right? Next, hash. Shatri uncles, please remember this point. We'll have a discussion again on this. Okay, uncles. Okay, and mined by, this is the address of the person who actually mined. So when the mining is done, okay, when the mining is done, this person will receive the ethers for that particular block. This person will receive the ethers for the particular block that he just mined, plus the gas used for mining all these transactions. Everything is awarded to the mined by person, that is the miner, and then the gas and the gas limit will look into the sessions features. And this is the important part, that is the nonce. Okay, here we are looking at the block reward. Right now 3 ethers is the amount of what they say, the price given for mining a successful block. Mining is nothing but trying to find out this hash, and this hash is unique to each and every, I repeat, this hash is unique to each and every block of its own. And when I say parent hash, it's nothing but, you can see the last 3 digits 342. When I say parent hash, it refers to the previous block. You got my point? When I say parent hash, it's nothing but it refers to the previous block. In this way, the blocks are interlinked with each other with the hash of the previous block they are owning. Okay, and then getting down the block reward. Block reward is the amount of ether that the network is giving to you for successfully mining a block, plus the gas associated with each and every transaction, the total amount of gas associated with each and every transaction that is rewarded to the sorry, miner. Okay, which the miner took to mine the block completely. Okay, and I was talking something about nonce. Let's take a look at this nonce. Okay, so what exactly is a nonce? I'm just stopping my meeting for a few seconds. Just a minute. Hello everybody. You can ask any questions you have till this point. You are not clear with any of the glossaries that we discussed. Meanwhile, I'm trying to open a Unix terminal online and then see if I can just show you what exactly the nonce is. Hello?
Yeah, okay.
Okay, I'm unable to do it on a Unix terminal. I'll show it directly in the hashing example. Okay, let's get back to there. Just sharing my screen. Now, as few minutes back, we just discussed about the hash exactly. So what exactly is a hash? It's a fixed length string that is given for each and whatever the input size may be. That is one single character or one complete GB of data, whatever it is, we get a fixed length string. But when we come to the blockchain thing, we are talking about hundreds and thousands of nodes, and each and every one can generate this kind of data very simply. So to introduce difficulty to the network, that is, it has to be uniquely generated each and every time, and that no one is going to tamper with it in a fixed amount of time. What they introduced in blockchain was the concept of nonce. So what exactly is nonce? In nonce, the nonce is nothing but hello world, right? We have this string, and they'll supply it with an integer number each and every time. So this is iterative. First with zero, that so it's starting is the data that is required to go into the block, and then the random digit number. Nonce is nothing but a garbage value. Okay, it's a garbage value. It has of no meaning. It's nowhere connected to the algorithm. Okay, they're trying to find this garbage value by iterating each and every time so that they reach to the difficulty level of the network. They just keep on incrementing. So what exactly happens in mining is the miners take the data that is available in the latest in the network. When I say to data, what I'm referring to is the transactions that are happening on the network. When I say data that is being picked up by the miners, I'm referring to the transactions that is happening in the network. So what the miners do, they take these transactions and then club them together, club them together as the data point, and then they iterate it right from zero till they find the they find the nonce number which is unique. And what exactly happens with the nonce number is we are seeing it something called as difficulty level. So the difficulty level determines how many if we, this is the new block that has been created. So the difficulty level actually determines how many zeros should be there in in starting of the block. If we go to Bitcoin Explorer, I think it will be more clear. Yeah. So if you're seeing over here, the block hash is containing a some set of zeros. Okay. So this is nothing but the difficulty level. The difficulty level is determined by the network protocols based on some inputs. That is, when the recent block was mined, what is the cost involved in it, and all those things. It's set for each and every block. Okay. Ideally, it's for the complete. For example, for the for a set of 1024 blocks, they set the difficulty level. But uh, generally, in case of Ethereum, let's talk about Ethereum. In case of Ethereum, the time to create one block is actually 10 seconds. Less time or more time than. Okay, getting back to the nonce concept. As I said you, what exactly it is, they'll take the list of transaction data and then they'll iterate it from zero till they find the number that will give this leading amount of zeros to it. That will give this amount of leading zeros to it. That's how things work. And when we say the miners are trying to compete, the miners are trying to compete nothing but they are trying to create a hash first. They are trying to create a hash first that has the leading number of zeros specified by the network. So that's what exactly is mining. So why do we trust this part is because there are hundreds of miners trying to solve this equation. Okay, so once when the miner solves this equation and publishes his ledger, that's how things go on. So we've looked at the non-Shatri uncles. We haven't talked about Shatri uncles, right? Shatri uncles. In Ethereum, contrast to the blockchain, in blockchain, what exactly happens is when a miner finds this hash, he's rewarded some X number of bitcoins. I think right now, see, the block reward is 12.5 bitcoins. Okay, it will be halved for every given number of blocks. Okay, now, for example, me and Giridhar and Mahesh are trying to compete to what they say, solve a particular block. So what exactly happens is when I solve the block and then I have the hash of my own, I publish it to the network and the network will have to accept it. But only I am being rewarded in case of Bitcoin. Only I will be rewarded in case of Bitcoin. But in case of Ethereum, what happens is each and everyone who are trying to take part in transaction will be rewarded. We'll look into that lately. Okay, those are nothing but the uncle rewards, the Shatri uncle or the uncle rewards. We'll get into that a little bit deeper next. We have something here called as Merkle root. So what exactly is Merkle root is, okay, I'll definitely go through that, but just to give you an overall idea. Now you're looking at transactions. Okay, you're looking at n number of transactions, and this is the transaction ID. It's nothing but a hash. So typically, what exactly happens to a Merkle root? We might have gone through the trees and graphs. So Merkle root is nothing but, here only. This is right. So number of transactions in the network, that is transaction 1, transaction 2, transaction 3, transaction 4, transaction 5, and transaction 6. Okay. Now we like this, we have n number of transactions that are being a part of a block. So what exactly happens is when we are trying to calculate the Merkle root of something, what we do, we initially generate the hash of the first transactions and then place it in the order, and then I think you most of the people might know the concept of trees. Okay, now again, uh, the hash at this point, that is the hash of transaction 1 plus transaction 2, we get new hash. Okay, and we get hash here, we get a new hash here, right? And then the hashes of these things are in turn calculated to find the root. So at this point it is going to be like this, 3 levels completely. And this is the Merkle root. So basically the concept is, since each and every transaction hash cannot be stored, cannot be verified independently. Okay, what we do is we create the Merkle root and put it as a part of the blockchain, so that whenever we want to verify some transaction, we only look at the Merkle root. If the Merkle root is changed, it means someone has tampered with the transaction. Okay, that is the concept of Merkle root. Right. So today we have discussed about peer-to-peer data, block data, hash, Genesis block. We have to look at something called as Genesis block. Genesis block is nothing but the first block that is being created into the network. How do we do that? How do we do that? .json file. So be it Bitcoin or blockchain, they have their own genesis.json file. This will get into the deeper part of this when we try to set up our own private Ethereum network. Okay, here we are nothing but creating our own network. Okay, and these are the inputs that we give for the Genesis block, and using this, what we do is we create the first block, or we mine the first block. Okay, we mine the first block and then we attach the peers to that particular chain data folder, so that it will download the chain data from there, and then two peers will start communicating with each other and sync the complete data with each other. Okay, hello, any questions so far? Anybody? Giri, Gauss, Mahesh, Siddharedi?
Kumar, nonce is based on each transaction or is complete for one block?
No. It's for the complete block.
I
Let me
mean,
show it to you. Hello,
the transaction.
hello,
Yeah,
hello.
yeah,
Am I
Kumar.
audible?
Yeah, yes.
Okay. So nonce is for each and every block. It's not for the transaction. Okay.
Okay.
Show you. Let's either scan.
But miners or validators will do a validation on transaction, right? Not on the block.
Yeah. So basically, miners won't validate the transactions actually. What they'll do is they'll pick up a set of transactions and then they'll try to put into the block. So miners are trying to verify the transactions by putting them into the block. So once a transaction is put into a block, it means the transaction is correct. and it has been verified. So the miners don't actually go to each and every individual transaction and then try to verify it.
Okay.
Okay. So what the miners will do is they'll look, for example, there's a transaction that has happened, right? There is a from address and to address. Okay. They'll see if the transaction they have done is valid, and then while creating the block, what they do is they try to fit that particular transaction into the next block by creating the hash of the block. How the hash is generated? It's based on the difficulty of the network, and then that will create the nonce exactly. Are you okay, Gauss, with the answer, or
Yeah, yes. So for each block, there will be only one nonce, right?
there will only be one nonce and it's completely unique from the first block till this block? That nonce will not be repeated.
Okay.
Any other questions, boys?
Kumar, this is Giridhar.
Yeah, Giri. Yes.
If we find that nonce, then that means that the block will can be created.
Yes, the block is created, but as I told you, some level of difficulty is associated with that. And if you find the leading number of zeros, I'll show you the example tomorrow. I'm not on the Unix terminal, that's why I couldn't show you.
Okay.
Okay, I'll show you the
Okay.
example tomorrow. So if your hash that you generated contains this many number of leading zeros, then you can say that you have blocked the hash, and then you can publish it to the network.
Okay. Because if we see only finding the nonce from minors means that can be easy, right? That's the reason I'm asking.
No, 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 no. Actually, when okay, do we have the nonce over here? Now you're seeing this nonce, right?
Hmm.
Okay, nonce, tens, hundreds, thousands, lakhs, 10 lakhs,
28 crores, I think.
crores, 10 crores, 100 crores. It's
Yeah.
284 crores, 95 lakhs, 50,000, 400. Right? It means
Yes.
the miners have iterated that many times. So each and every time, it's not that the next block will start from this number. To find out the hash, they have to again start from zero only.
Okay.
You got my point?
Yeah.
Let's look at another block. Just a minute. You see, it's a smaller number of here.
Hmm.
Hmm? So the concept of nonce is the miners will start from zero again by taking all the data into their this thing into the payload. With that
Okay.
payload, they'll add this number, that is 0, 1, 2, 3, until they find this particular number. Okay.
Okay.
Yeah.
So they're using the transactions to find the nonce
This is
number, right?
the transaction data. So if you just redirect your this thing, my screen is still shared, right?
Yes. Yes.
Yeah. So here you're looking. Let's think of that. Hello world is the complete transaction data that people have
Hmm.
picked. Okay.
Hmm.
Okay. We have discrepancies in that too, because at a given point of time, some 100 transactions are there, and people can pick up any transaction, right? So, for example,
Yes.
me and you are competing to mine the next block. We both are trying to
Hmm.
mine the next block. What we do is,
Yeah.
from the list of transactions, you might pick up few transactions and I might pick up few transactions. Both might be completely different. It's not mandatory that all the miners are picking up the same transactions at same time.
Okay.
Okay. Okay. So what
So
exactly is
when
happening?
the,
Yes.
yeah, please continue.
Yeah. So what exactly is happening is when we pick those transactions, okay, this is the sample transaction data, and then what we do is we start from zero, keep on iterating it until we find a hash that will give us the leading amount of zeros that has been specified by the network.
Okay.
Okay. Once I find the hash, what I'll do is I'll publish that hash along with the list of transactions to the network. Okay.
Okay.
That's when the other nodes or the miners and everyone in the network update their ledger update their ledger, and then
Mhm.
what they do is they pick up new transactions and start the process all over again.
Okay.
Okay, you got my
So
point?
means when they pick up the transactions, they can only able to see the transaction number only, right? They cannot get into the transaction details, right? Or they can get into the transaction
They can
details
get into
also.
the
What they
transaction details also. It's like on a public blockchain, you can see all the details of a transaction.
so
We
let for example, if I transact like 1,000 rupees to you, so they can see that.
So yeah, they can see that. That's the concept of the
Okay.
public blockchain, right? But we cannot tie an address to a particular person. That's why we have the concept of this public addresses instead of using as our mail IDs or something. Okay, in a
Okay.
transaction, if you can see, you have these addresses.
Yeah. So they cannot
Okay,
identify the person or the mail
identify the
ID.
person exactly. Exactly.
Okay. Okay.
Okay. Yeah.
In this way, the privacy will be there, I think we can say.
Privacy will be there on the public things.
Okay.
So, okay, good question actually. We have something called as PKI, that is
Private key.
public public key
Public.
infrastructure. Structure. Okay.
Okay.
Yeah. So, any more questions, people? Anybody else?
Uh, Hi Kumar, this is Siddha here.
Yeah, hi Siddha.
Uh, Small doubt actually. I just want to know what is the major difference between Ethereum and the Hyperledger for business blockchains. I mean, like
Okay,
in what
as
perspective they will be different and yeah,
yeah, okay. So, as I explained just now, it's like everything on. Can you just mute yourself?
yeah, sure, please.
Yeah. So, as I explained just now, to as I responded to Giridhar, okay, in this blockchain, everything is public. Okay, you can see each and every transaction, and there's no restriction on who can transact with whom in the public blockchains. That is the Bitcoin or networks. But even though if we try to deploy the Bitcoin and blockchain for private parties, that is we can set up our own network, but even in that network we cannot restrict people. For example, we are trying to create a network only for 10 people, the Ethereum blockchain, and then transactions are happening in that network also. There's no way you can restrict the network people from looking at the transactions of each other. But whereas in case of Hyperledger, okay, the creation of node etc are being controlled by the admins. That is, the admins actually allow what people should go into which network, and then they install the chain code based on some rules and other stuff in Hyperledger and other for example quorum and r3 coda and stuff. R3 code is a consortium, sorry. The quorum and the Hyperledger, what they do is they have separate what they say admins for each and every organization, and are actually the people who will validate that you, yes, you can join the network. Okay, and even if after the joining the network, what, for example, there are six nodes in the network, and two nodes can communicate internally without revealing the details to the entire public ledger that is being running outside. So that's how you can set up your own customized private network in case of Hyperledger Fabric. Does that answer your question, sir?
Yeah, yeah, that's got it. So you mean to say that I mean like the more secure way to for a business network is the Hyperledger, right? Going forward, I mean like more secure and in the
Yes,
sense,
exactly. I would.
okay, okay. Do we have any live projects running on sort in the market for Hyperledger projects based on Hyperledger?
Yes, we do have a lot of live projects.
Okay, okay.
I'm sorry, Sudha. I think there's some problem from your side only. It's like it's echoing continuously. Okay. Hello? Hello?
Yeah, uh, sorry for that. I mean, I didn't get down, so sorry. Is that, I mean, the more powerful Hyperledger, I mean, blockchain available in the
No,
market, right? Hyperledger is
no,
the.
it's not kind of powerful. It's the degree of abstraction that it provides that is suitable for enterprise applications. But whereas
Okay.
if you look at the current market trend, Ethereum is the widely one that is being used to develop the decentralized applications and stuff.
Okay. Okay. Got it. Fine. Actually, in IBM, I could see a lot of POCs are running, but there are no live projects, I mean, in the market. I heard that.
Well,
I don't know
I'm
if that
actually
is
part of two projects actually.
okay.
Okay, one is a supply chain thing on pharma, and this other is a enterprise application which would control other enterprises. I cannot give information more than that. I'm sorry.
That's great. I mean, that's enough. That's really
Yeah.
enough to know. I mean, thanks for that. And well, small query. Actually, what is the main difference? I mean, like, between a node and a pair? Like, a
No,
node
no, they
can
are the
be
same.
both. They are the same, huh? Okay.
They are the same. It's
Okay.
just that in Hyperledger Fabric we call them as peers, organizational peers, whereas in Ethereum we say that we have uh, created a node or trying to join the network, and we say them as peers when two nodes are talking to each other. You got my point.
Ye-
Node is nothing
Yeah,
but
yeah,
the individual representation of the computer or the person who is trying to transact over the blockchain.
yeah. Okay.
When we refer to them as peers when they're connected with each other. That's it.
Okay. All right. And one more thing. Can we use that a single node or peer for two blockchains? I mean, like networks.
That's not possible. In case of
So only
what they say
it
in
is restricted to single
Ethereum or
blockchain, right?
blockchain. In case of Ethereum, yes, it's not possible. But in Hyperledger Fabric, you can be part of something called as multiple channels.
Okay. In the form of channels, we can able to connect, right?
Yes, we can able to connect to
With the
different
same
channels
with the
with the same
same
node.
single node. Okay. But in Ethereum, it is not possible.
It's not possible.
Okay, got it. One more question. I mean, like, how a node find the other nodes in the particular, business network, I mean, blockchain network,
They have
whether it
something
has
called as
through
peer
any,
discovery.
okay,
We'll look
with
into the detail in the going classes.
fine, that's great. Actually, sorry to ask, actually, I was facing this kind of questions in internet. I mean, while attending some interview. That's the reason I was posting. If you don't
Oh,
mind.
definitely we'll see that you're completely prepared for the interview. That's on me.
No, actually, no, I've been not that much level, but I have this questions running on it, but I have some answers, but I no clarity.
Okay.
So I just want to check with
So
you.
like, I'll I'll probably share the what they say timetable on how the course is going to be.
Yeah, yeah, sure.
So based on that, it's like whenever you have a questions or you can prepare beforehand, and then each and every day for 10 minutes we can discuss.
Yeah, that's fine. That's great.
I'm not sure why I'm getting an echo only for your.
I'm, I'm really sorry. Actually, I was in travel. Sorry for that disturbance. Actually, I'll not
Okay.
repeat from tomorrow onwards. Actually, I'm in a hurry to Chennai. Actually, that's a problem. Thank you.
Yeah, Giri. Hello.
Yes, Kumar.
Yes, Kumar.
Giri, from your side?
Yeah, I
No,
don't have
as
any
of
questions.
now.
If there are no questions, then we can call. Siddha, ready?
So sorry, I didn't get that.
Are you in contact with the others? That is Giri and Gauss.
Yeah, I'm in contact with Giri and Gauss, no problem. I'll check with them
I'm
further.
not sure if they're able to hear me. It's like if they're okay, then we can call it a day for today.
Yes,
Actually,
yes, we
they gave a
can catch
response
up.
to you like, yeah, yeah. I think Giri is responding now. I hope you can hear that.
Yeah, Giri, yes.
Okay.
Kumar, we can patch up now. We are done.
Okay, Giri. Thank you.
Yep.
Thank you, everybody.
Thank you. Thank you.
Thank you, Kumar.
I'll
Thank you all.
start sending the dates from tomorrow. From tomorrow, that's a day before what we're going to discuss, so that you can go through them.
Okay.
Yeah. Thank
Yep.
you very much.
Thank you.